Hey everybody, this is Alex Merced from alexmercedcoder.com, and what I'm going to do is start going through different design patterns and discussing how to implement them. I'm going to be using JavaScript as the language, but at the end of the day, the concept of the solution is what matters. So design patterns are just very typical patterns you see in object-oriented programming and using in how you approach using object-oriented programming to solve your problem. So I'm going to start with the creational patterns. Now I'm going to skip over factory and abstract factory because I've done so many videos on factories that any of those videos should get the point across. So what I'm going to move over to is things like Singleton in this video, and prototype and builder patterns. So first we'll do Singleton. Okay, the idea behind a Singleton is you only need one of something. Okay, so you don't necessarily need to create a constructor that's going to construct several instances of the object. You just need an instance. Now in JavaScript that's pretty simple because you can literally just create a standalone object. In other languages you'd probably create like a static class because you can't build objects in the same way you do in JavaScript right out of the gate like you can. So so for example, a good example of like a static a singleton would be like math. So in JavaScript you have this math object. Now I never have to do like a new math. And the question is, can you do a new math? So let's actually try that out. So const another math equals new math, and then let's console log. I'm assuming this might work. Another math, depending how they created math. Another math, save. Testing on node. Testing.js. Okay, so math is not a constructor. It's just a. So what is math? Let's find out. Assuming it's just an object, just a straight up object, not a constructor function. Save. Yep, it's just a straight up object called math. But it's a singleton in the sense that you don't have to create an instance of the math object. It's just an object that already has all these functions and has all these functions and methods and all this stuff. So if I want to see the functions, I'm assuming I would want to do this. Let's give this a shot. Math.prototype. Nope. But the idea is that this math object has all the functions and properties that you'd want, like math.py, which technically has the value of pi. I think was it just pi? As you can tell, I don't use the math object beyond the random function all that often. But you have math.py, math.random, math.floor, all these different functions that are used to do math stuff. But you don't need multiple maths. I don't need to create an instance of it, so they just created one freestanding object. That's essentially the concept behind a singleton in a situation where you just kind of need one object that does some things, but you don't need to create it in a way that do that. So like, let's say I want to recreate math using classes. Okay, you do class new math. Okay. And since I'm not going to be creating an instance of the math, I'm not going to worry about a constructor function because I'm never going to be making a new math. It's just going to be a static function. So, for example, if I wanted to give it a static property, so static, we'll call it pi equals 3.14. Okay, that what this is, it's a static property. So basically, it's a variable that's on the class, not an instance of the class. So if I save this, let's give this a shot. I should be able to console.log. Instead of having to do like a new math, I just do new math.py. Okay. And see, I'm able to call that property of math. Now, if I can also give it a function. So if I wanted to do something like floor, I could just do this to keep it real simple. Static random equals math.random. No need to reinvent the wheel at the moment. Okay, save. And now I could do math dot or new math dot random. Save. .02 whatever. Now, if I did not call that a static method, then I would not be able to call it on the class itself. I'd have to call it on an instance. So let's see if it still works. So I get new math.random is not a function. So in that case, if I wanted to use random, what I'd have to do is first create a new math. So it'd be like new math. I have to create a new instance of new math. And then off of that, I could chain the random function. But why would I want to create a new instance of new math every time I want to use random? There's no need for more than one random function. That's the reason you'd want a singleton, because the things that singleton, that one single object does, only needs one object to do it. Okay, so you just define everything as static properties, static methods, and you just create this one object that does things. Like, for example, let's say we're constructing Galactus for Marvel Comics, you know, I would create one object that's called Galactus and put all his properties, like methods like eating planets, as static methods, because you're not going to create a new Galactus, there's just a Galactus. So always think about it that way. If there's just one of that thing, then you're creating a singleton. It's one object that does the thing. But it's nice to do it that way, because then you can encapsulate all its properties and methods in one object that travels across your program. Okay, so that's the deal with a singleton. So I'll see you guys in the next video. But again, so the concept of singleton is that instead of creating a way to create many objects, you are creating a single object that does the methods and the properties that you need, because there's only one instance of the object is necessary for your particular solution.